Okay, fifth graders, today is Wednesday, August 28th, and we are continuing on with Eureka Math Module 1, Lesson 3. And today we're going to learn how to use exponents, and for some of us this is probably a review, but we're going to use exponents to help us name place value units, and also you should be able to explain patterns about where the decimal point goes in a number, okay? But first let's talk about the problem of the day. So when we're talking about exponents, that means we're using the same factor over and over again. We're multiplying the same factor over and over again to get another number, okay? So my challenge to you is using only the number 10 as a factor. How can you multiply to get a product of 10? If I want to do 10 times something, or I can only use 10 times 10 times 10 times 10, like that. What do I need to multiply to get to 10? Well, this one's tricky. It's 10 times 1, okay? Now, how can I using 10 as a factor, how can I get 100? I have to do, Allie, 10 times 10. Good. How can I get to 1,000? 10 times 10 times 10. Very good. Okay. What about 10,000? 10 times 10 times 10 times 10. What about 100,000? 10 times 10 times 10 times 10 times 10. Are you guys seeing that? And then lastly, 1 million is 10 times 10 times 10 times 10 times 10 times 10, right? Now, have you guys noticed that these places are the place value chart? There's, of course, the ones over here, but the tens, hundreds, thousands, 10,000s, 100,000, then 1 million. Do you guys see that? So each time I'm moving from here to here, it's getting bigger, isn't it? How many times bigger is it getting?
10.
And then from here to here, how many times bigger is it? 10. And each time it's 10 times bigger. And that's shown in our multiplication. Here we only had one factor of 10. Here we added another factor of 10 because it got 10 times bigger. Here we added another factor of 10, and another factor of 10, another factor of 10, another factor of 10. Do you guys see that? How many factors of 10 were there to get 10? 1. How many factors of 10 were there to get 100?
2.
How many factors of 10? 1, 2. Very good. How many were there to get 1,000?
3.
10,000?
4.
100,000? 1 million.
6.
Okay? So each time we move one adjacent space over in the place value, one space to the left, we're getting 10 times bigger, which really we're multiplying by an extra factor of 10. And we could use exponents to show this. We can say that 10 is 10 to the power of 1 because we only have one factor of 10. We can say 100 is 10 to the power of 2 because we have two factors of 10. Following the pattern, 1,000 then would be 10 to the power of 3 because we have three factors of 10. 10,000 is 10 to the power of 4 because we have four powers of 10. 100,000 is 10 to the power of 5 because we have 5 powers of 10. I know, it's a messy 5. Calm down. 1 million is 10 to the power of 6 because we have 6 powers of 10. Okay? What do you guys notice about the exponent, which is these numbers here, right? And the number of zeros in the value. Talk to someone next to you. What do you guys notice? I heard a lot of people say the exponent is the same as the number of zeros in the product. 10 to the power of 4 is 10,000, and there's 4 zeros there. Do you guys see that?
Yeah.
Okay. Each time you add a zero, the reason why you add a zero is because you're multiplying by 10. And when you multiply by 10, that also impacts the exponent. Okay, so the exponent tells you the number of factors of 10 in that number, which is also what the zeros tell you. Okay. When we write numbers using exponents, it's called exponential form. Everyone say exponential form.
Exponential form.
And there's two parts to an exponential form. The first number is the base. Okay, that's in this case it's the 10. It tells you what the factor is. It tells you what number you're multiplying over and over again. It tells you because factors are numbers that you multiply. The exponent is the little tiny number written to the upper right-hand corner, and it tells you how many times to multiply the factor. Okay? So for example, in this case, if the base is 10, what number are we multiplying? 10 or 5?
10.
10. The 5 tells you how many times to multiply that factor. So this one would be 10 times 10 times 10 times 10 times 10. 5 times, very good. Which is what?
100,000.
Whoa. With a quiet answer hand, what is the value of that? Sushant? 100,000 because it has 5 zeros. Okay. Now, some common 5th grade mistakes regarding exponents. Sometimes we mistakenly think this means 10 times 5. Is that true? No. Sometimes we think this is 5 times 5 times 5 times 5 times 5 times 5 times 5, etc. Is that true?
No.
No. Okay, so these are common mistakes. Some common mistakes in writing exponents are as follows. Sometimes people write 10, I'll just write it over here, to the power of 5. It is very unclear, right? Okay, that looks like 105. So when you're writing exponents, make sure you make it very clear that it is an exponent by writing it small and to the upper right-hand side. Make sense?
Yep.
Very good. Instead of writing 1,000, we know that's 10 times 10 times 10, right? Do you guys agree?
Yeah.
So we can write that's 10 to the power of 3. Okay, so 1,000 in exponential form is 10 to the power of 3. What about 100,000? That's 10 times 10 times 10 times 10 times 10, so it's 10 to the power of
5.
Go ahead and write that number sentence in your notebook. 100,000 equals 10 to the power of 5. Now the next one, we have 100 times 10. Well, we know that 100 is really 10 times 10. Do you agree? Yes?
Yeah.
100 is 10 times 10. And then I have to times 10. So this is going to be 10 times 10 times 10. So how do I write that in exponential form? 10 to the power of 3. Good. Now the one down there, we have 10 times 10,000. We know that 10,000 is going to be 10 times 10 times 10 times 10, right?
Yeah.
Which is 10 to the power of 4. And then if I have to times 10, multiply it by 10 again, altogether, that's going to be 10 to the power of
5.
Good. Okay, so do you guys see how to make it work when you have a multiplication equation like that? Very good. Well, we know that 10 to the power of 3 is 10 times 10 times 10. What is that?
1,000.
1,000. So really this question is asking you 4 times 1,000, which is?
4,000.
Good. Okay. Is that 4 to the power of 3, by the way? Is 4,000 the same thing as 4 to the power of 3?
No.
But I have 3 zeros. What would 4 to the power of 3 be? It'd be 4 times 4 times 4. No. What's 4 times 4? And then times 4, yeah. So it's, okay. But is 4,000 equal to 4 to the power of 3? Hey, Ikaksh. Is 4,000 equal to 4 to the power of 3?
No.
Be careful. Okay, good. Okay. That one was the easy example. Now, try this one. 60.72 times 10 to the power of 4. Well, 10 to the power of 4 is really 10,000, right? So how do I do 60.72 times 10,000? Go ahead and do it in your math notebook.